welcome everyone. Scale warriors are engineers, they're entrepreneurs, they're doing things that have never been done before, they're building things, they're breaking barriers, they're pushing the limits of scale. Internet scale, Internet of People scale, Internet of Things scale. And so we're very happy to have very experienced audience here, a panel here, to kick off that discussion. On June 25th, I believe, we will have Don Hatterley at our next meetup, where we will talk about what happens when you start scaling and you have all this data piling up, and you've got NoSQL and NewSQL databases, so he will lead that discussion. But today, I'm very happy to welcome Marie-Anne Neimat, who's also an advisor for Aerospike. Marie-Anne is an engineer and entrepreneur. She was founder of Times 10, and until recently was running in-memory databases at Oracle. So we're very happy to have her lead our panel today. Marie-Anne, please.
Thanks a lot, Monica. I would like to welcome all of you. Thanks for joining us to the Scale Warrior Meetup. I hope you've had a chance to talk to other people and to mingle. So we have a topic that's very interesting to debate today. The topic being the Internet of Things. So the basic premise, as you all know, of the Internet of Things is that every device has the potential of having an IP address and therefore being able to communicate information about itself over the internet and able to receive commands or whatever via the internet. So this is, the possibilities are endless, from being able to completely control energy usage in a large building to monitoring traffic via sensors and being able to pass that information on to GPSs and so on. Some of these possibilities have already hit the market. There is, for example, a thermostat you can buy today from a company called Nest. That thermostat will monitor all the settings that you change. You might change the settings in the evening before going to bed, or in the morning when you get up, or when you come back home in the evening, and so on. And this thermostat will observe your patterns and will automate the change of the settings as time goes on, because it's learning your habits and your patterns, and it can start figuring out your schedule and learning as time goes on. You can also control the settings via a mobile device or a web interface in general via whatever device is available to you. So anyway, the Internet of Things is already available here, and we would like tonight to see what the future holds for us, what are going to be the requirements over infrastructure, be it messaging or storage or data analysis and so on. And we have a very interesting panel here because they cover a broad spectrum of interests in that space. So we have a panelist, for example, from General Electric, and we know that General Electric has home devices, home machines, and they build that all the way to jet sets. So their interest in devices is very broad and varied. We have a representative from Cisco, and all this communication of devices is going to put a big strain on the network, and Cisco obviously has a vested interest in that area. We also have two representatives from startups in very interesting areas. One is an application area. So QuickPay is in the area of monitoring space in garages. So they rely on sensors to provide a very practical application, monitoring what's available in a garage. And then finally, we have a representative from a startup on infrastructure, and that's real-time scalable storage and data analysis, namely Aerospike. So let me introduce the panelists. We have Sukanta Ganguly, who is CTO of QuickPay. This is the company, the startup focused on garage utilization. We have Shashank Tiwari, who is a big data architect at GE Global Research. We have Brian Bulkowski, who is founder and CTO of Aerospike. And we have Mahbubul Alam, who is head of Internet of Things platform and machine-to-machine group at Cisco. So thank you for all the panelists for being here. We have asked the panelists to do a roughly 10-minute presentation each on how they envision the Internet of Things to evolve, what it will mean to us as consumers. Will it make our life better or worse? Hopefully a lot better. What demands will it place on infrastructure? And since we are very interested in data management here, a little bit more emphasis on data management. And then finally, what they see as the absolute most important challenge. So we will start out, I believe, with Shashank. Is that the right name? No. I'm very sorry. Mahbubul.
I think I won the lottery, so I get to start. So thank you, Marianne. I'm going to stand. I prefer standing and actually moving. So first of all, thank you, Brian, for hosting this event, and thank you for all of you coming here. It's a great opportunity to connect with people who bring different perspective. I'm really looking forward to more gaining from you than rather telling you, because I think you all bring a very different perspective, which is outside in. And often in any company, we look from inside out, and the world looks different. So it's the two sides of the coin. And also, I did not prepare a presentation for this event. It was thinking of a lot of Q&A, but I have many sets of presentations. So I just pulled up one that I will use as a background to help build the story. So how many of you have heard about Cisco's play in Internet of Things? Some show of hands. Okay. How many of you, please be honest, because this is, sorry. Okay. How many of you think seriously that it is something Cisco should be doing? Okay. Great. That's pretty, I mean, it's at least 30%, 40% feels that. It's not obvious. Obviously, it is, yes, we were instrumental in building internet, and we like to see that we want to be instrumental in building Internet of Things. And so with that, my task in Cisco is not about having a pie in the sky, but really turning that into tangible revenue now and in the near future. So it's a steps towards Internet of Things. And even though a lot of the use cases you will see from different peoples will be very forward looking, but we have to take incremental steps, and we have to run a P&L to run that business. And I will talk about the use cases that we are seeing across different industries. And there's no better example I can tell you like GE. They, you look at that TV commercial there with a train talking, right? And they have all kinds of things, and we do work very closely with GE on many fronts, especially on IoT. So what Cisco did is is we started having machine-to-machine, Internet of Things, and we struggled to find out where does M2M end and where does Internet of Things start. And we had this Venn diagram, whether it was subset, superset, what, and basically we couldn't come to an answer. If you go to Wikipedia or anywhere, you will not get a clear answer. What is M2M? What is IoT? I mean, they're blurred, and there are probably 50 plus definition for IoT. So we did extensive studies to see how serious should we take this, and then our Internet Business Services group went and did extensive studies, and they came up with a value that was so profound, which was machine to machine, machine to people, people to machine, which was combining people and machine as well. Even though today we're going to talk about Internet of Things, which is really around the things, but there's also interconnect, and there's a huge value between the machine and the people as well. And so then we came up with this term called Internet of Everything, because it was not only things, it's not people. And so this diagram was kind of the way that we said, okay, there is a people, there are things, and there are data generated, and there are processes, and bringing them all together is kind of our grand view of Internet of Everything. Though we will focus on the things, because we have a lot to do. 99.2% of the things that will be connected are not connected. That's the white space we have in front of us. Probably you are seeing it in your home, in the consumer electronics, everything getting connected from your Xbox to all your PlayStation to TVs and so on, and that is slowly moving towards the industry. So the consumer electronics is the first wave that is happening in home to make your home life easy. The second phase is about the vertical industries. So now you're seeing industries doing, GE is doing on their own, Shell will do on their own, and so will fleet management companies, so will Qualcomm all join will have their own. People will start doing their own vertical things. I have Nike Fuel Band has their own solution up there. So they're all siloed, and they don't talk to each other, right? But they're, is it Internet of Things or Internet of Closed Things? I don't know. But I let you all decide. But that itself will give a huge value for managing, reducing truck roll. It will be either around OPEX reduction or generating new revenue or creating new business models. I will talk about some of those. And then the far future will be something like a connected society, which is people, things, everything will interact with each other. And then it could be a web as the equalizer. Doesn't matter how you came through RFID or through Zigbee or through M2 cellular, or how you came, somehow the information resides somewhere into a web, which is an equalizer. And then you have semantic web that could be a way to interconnect and create a social network of things and people and data. And then as that progresses, that part of the web will, that cloud solution will push down towards the devices. So you will see a migration of some of the intelligence that's sitting over there in the cloud will move closer to the edge of the network, because the amount of data that we'll be generating, no network will be able to support it. So we have to think about architecture. And so that's how some of the challenges of Cisco's comes into play. So this market was evaluated to be $14.4 trillion. And it is, we have a report out there, so you can search Google and do an Internet of Everything Cisco report, and you'll find the detailed, what we call value at stake, which is creating new revenue opportunity or reducing the cost of the existing. And add those two together, we call it the value at stake, and that's $14.4 trillion. And basically, from Cisco perspective, we are a networking company, and we have aspiration to bring some of this know-how into the Internet of World. Obviously, security is one thing which you should all take it for granted. Security is pervasive. There is no single point in the network that you say, oh, security resides in the device or on the network or on the information or in the cloud. It's pervasive, it's cross-layer. So security is very important, and it's not the IT security, it is the IoT security. There are differences between IT, enterprise IT, or the IT security that we know versus unintelligent device, low power, low computation, and so on. So there are other security challenges that we are working through. But the 4 pillars that we have, and this is the key takeaway and this is how I will build up. The 4 Cisco pillars on which we will build our Internet of Things solutions are around sensors and devices, network and protocols, data analytics, and control system. In fact, control system is the key differentiator for the way we will look at Internet of Things rather than many of the others. There are a lot of over-the-cloud solutions, and it's best effort. There is no loop-back mechanism. How do you actuate? How does it learn? How does machine makes decision? And working around that control is going to be, maybe you will call it an Internet of Things 2.0, because 1.0 is what we are seeing already, right? It's in full play. So, and then that will cut across some of the verticals. So we also looked at which verticals are really poised to take off. So we have mapped verticals and sub-verticals into kind of the chasm, the Jeffrey Morse crossing the chasm, and we said, okay, telematics is almost there. Healthcare has imminent, so it's ready. Aviation is somewhere over there. Transportation is. So we mapped it, and that allows us to have a different go-to-market approach, whether it is incubation-led, something that we need to handhold 1 or 2 customer, do a trial before we understand how to productize it and how to replicate. Some things will be services-led, something will be consultative-led, some things will be partner-led. So there are different sales motion that goes into based on the way it is built. So this is very simple. These are some of the practical examples where we are making money. Today, Cisco's Internet of Things business is already somewhere over $300 million, and purely based on our switches and routers and access points. These are hardened switches, hardened routers, and hardened access points. They are going into manufacturing plants. They are going into the pole tops, like I will talk about in BC Hydro, 2 million Itron sensors, and we have our IP stack in there, and then we are able to collect and manage and do all those things. This is an example that something goes wrong. This is the end full cycle. Something goes wrong. We have to integrate it with the back end of the system. Then it's going to say, auto replenishment. So replace that. That has to trigger someone's cell phone and say, okay, that's sitting somewhere in the warehouse. Number that. Go get that, and then ship it over there. That's the whole cycle has to be taken care. So it's not only the technology part, but it's also the integration, system integration, and also building a workflow around it. Similar in the home. These are today's example. Today, how you make money today. I know we think of a lot of fancy, but these money, how we are able to make a lot of money today, because our focus is really on B2B. This is very important. We segmented the Internet of Things into B2C, B2B, B2B2C. Now B2C, when you face a consumer, there are different benefits, and how you get money from them is a different versus helping someone like GE to help automate their aviation or rail, and the business there is a totally different ballgame. So our focus of Cisco's going from our traditional franchise enterprise customer is to focus on B2B. Though we do have some aspect with SP where we are going to B2C, but we have a different business model. So this is around a house which has this electric meter, and these are like 2 million of those out there. The power goes down. Pole top router, it is able to, it's not only connecting those on the field area network protocol, but it also has some analytics. And it sends only that data that is relevant. So it's not pumping everything to the cloud. So it's sending back to the NOC, and automatically, a dispatch is sent, and a message is sent to the home that your power is out, and power gets restored, and you get a message, you're back. So you don't have to call. The future is that you don't have to call that, hey, I'm out of power. They will proactively reach out to you. They will dispatch it, just like you have with car, right? When you have a crash, you have those automated solution, like they dispatch the medical, they know the GPS location, and they're talking to you. So similar things are also coming into this. These are very, very simple things. And now imagine scale. Scale is very important. So Internet of Things is not as enterprise or traditional IT, because we're talking about scale, which is 10x, 100x of human. Timing is very important. We heard about real-time decision making. There are two types of, in B2C, you have human level decision making. So for a human, if you're doing a parking meter or that space, I'm sure if I get my response in 1 second that your space is reserved, I think it's real time. Would you agree? 1 second, if you get your parking meter, you reserve a parking and you get back. In a machine world, that is a lifetime. Machines have to make decisions in hundreds of milliseconds that depend on each other. Imagine a KUKA robotics, which is cutting through, and you put your hand over there. Well, you have to have that kind of response time. So it's about real time, it's about scale, it's about decision making, control loop back. It's not one way, just sending it over there and don't know what it is. So the control over there, and also you will see that the ecosystem partners will play a key role. I'll just quickly use the last few minutes just to show the objectives of our connectivity platform is about managing private and public networks, because we have many private networks, which is in the utilities and so on, but public networks as well. We have to enable service provider for M2M services. It's connecting things which are intelligent and unintelligent, secure infrastructure, and compute data in motion. Compute data in motion is basically data that is going at this moment, flying through. How do you make an impact here and now? One of the example that we can talk about is, I will not name the service provider, but over-the-top players like Skype. When you do Skype on your cellular network, sometime you will see your quality of video or voice is going down. Have you experienced that? Okay. So what does data in motion can do? The people who are providing infrastructure, we are providing ability for them to understand that the quality is going down. Instantaneously, they can push not an ad, but a message to you. Are you ready to pay 30 cents to get your bandwidth, additional bandwidth? And you had made no contract. At that moment, that instant gratification has huge money. At that moment, you decide, if I'm talking to my mom and I'm doing this video, I will press that 50 cent or 30 cent, whatever. and so a lot of those are data in motion. So the real-time aspect of a data is very, very important. And last but not least, build a platform where other people can build on top of it. They should be able to build businesses on top of it. So I think I have taken more than my fair share of 10 minutes. I look forward to a lot of interaction. I look forward to healthy debate, and we don't have to agree. But let's go away from having to know something about each other as well as learning something new from each other. Thank you.
Thank you, Mahbubul. We should hear next from Brian.
Hi, I'm Brian Bulkowski from Aerospike, and I will stick to my 10 minutes so we can, because I'm really interested in the question and answer, frankly. That's my favorite part of these programs. So obligatory picture of a rocket. We're Aerospike, and we're a database company, and the Aerospike is a small tip at the top of a rocket, and you size it for the speed and shape of the rocket, creates a sound barrier breaking compression wave. If you don't get that exactly right, the rocket will fall over. It won't be able to break the sound barrier properly. So that was one of the innovations. I think this is a Minuteman 3. So we like to also think that we're a small piece of technology that makes a huge difference in scale. When I founded the company, we were looking at the problems of advertising in particular, but also media in general, of building a big data platform and building a database that could work at the kind of Yahoo front page scale that was prevalent in 5 or 6 years ago. So our interest in Internet of Things is we've been dealing with what we call the Internet of People, in that all of the behavior that is happening on the internet that is being tracked and shared for social analysis, sentiment analysis, and behavioral analysis in advertising, search retargeting, all of that has been our customers that we've deployed with Aerospike. So in taking that technology forward and thinking about where the next sources of data and where the next issues with scale are going to be. We're dealing with customers who are already dealing with 1 million, 2 million, 3 million requests per second out of their database clusters and need to have full levels of reliability. Internet of Things came to mind as a good next step for our database. So what we've seen in our customer base is that these internet enterprises, the social media companies, the advertising companies, the traditional enterprises are starting to understand the power of the technology that's being brought to bear within advertising and social media and trying to bring that into their business. Now, some of them, like let's take sort of the industrial control case we were just talking about. I was at a Bay Area car company. You might be able to guess who that is. And yeah, as you know, they recently won the award for the most high-quality car that has ever been created. Right? How did they do that? They did that through data analysis. There's a lot of process and smarts to what they did, but those cars are throwing off a huge amount of data, and they figured out that that was a key competitive differentiator years ago. So they've got these piles of data for every spring in the car, stressed member, stress analysis, how the thing, and throwing off this huge amount of data. To me, that's a great example of where we're going to get to with Internet of Things. Once you can do these kind of process analysis, we'll see that even in these silos that we have today. So in the Internet of People analysis, at first we saw people would just track on a website. Right? That's what you do. You look at your website, you do some A/B testing. That was sort of the first phase. The second thing we saw was that personalized content, finding my friends' information on my website. The third has been the sharing of information, site to site, location, silo to silo, about behavior, search terms, and targeting, happening at scale today within the social media companies. So the ad platforms have been leading the way at scale right now in a lot of the, it's still machine to machine, right? Because you've got a set of servers tracking your behavior, looking at networks. I've talked to folks who are doing analysis. For example, they have contracts with carriers, and so that they can get randomized samples of what's happening within carriers' networks without doing anything specific to a user, right? Just knowing one cell phone tower is hot right now, and guess what? There's a whole bunch of the phones have a certain velocity without knowing whose they are. What can you do with that amount of data, right? That's already happening within the advertisement and social communities. So, great. I'm going to skip forward a little bit. So what we've seen within the communities in advertising today from a database perspective is factors that we expect will also be required within the kind of architectures that the gentleman from Cisco is talking about. In particular, the kind of architectures that we see are really 3 different data pools that exist. There's always going to be Hadoop on the back end. Right, that's what that really is the lingua franca. But we also see within our customers different technology stacks for different query patterns. So Hadoop isn't good for everything. It's good for a lot of those big workloads. But there are other query optimized databases. Vertica is good for certain queries. You've got a whole bunch of different systems. Most of our customers have a plethora of back-end warehouse technologies, but Hadoop is their database of record for the kinds of behaviors we're talking about that are Internet of Things, Internet of People related. The second tier, a mid-tier right now, is those Hadoop systems. Once they get big, once they get past 10 petabytes to 100 petabytes as a single system, they get kind of slow, because the ability to segment and index that data, that's not what Hadoop's good at, right? Hadoop's good at huge table scans. So within the big warehouses, you still have queries and batch jobs required that are going to take 2 to 3 weeks. And that's what when I was talking to that particular car company, that's one of their challenges right now, is that they've got 2 to 3 week queries. And, talk about the difference between milliseconds and seconds. You talk about, you just want to ask a basic question. How often has this part failed in conjunction with certain different kinds of road actions? Well, if it takes you 3 weeks to answer one question, you're going to have a hard time doing research. So we're starting to see a mid-tier that is also an analytics tier that is sort of second to minute query oriented, and it's focusing on ad hoc research queries, as well as focusing on sort of short interactive queries where you might ask a question even as an end user, not just as an analyst. You might be populating a real-time dashboard, for example. On the very front side is really where you have real-time requests come in. Where is my nearest parking space? An alert that says you need to now turn down your thermostat, or it will be turned down for you. Or the case. I'm sorry, that was kind of creepy with the getting an ad saying you with the bandwidth. I'm not looking forward to that world. I'm sorry. But that kind of real-time event. So what we see at a data layer is really the world is now segregating out into three portions. And at Aerospike, we've really specialized in the very front edge of that with user profile analytics for the silos that exist today, and really are looking forward to the world where there's a lot more connectivity and a lot more internetization of this, simply because the pie will grow, there'll be more data to process, and more great business analysis that come out of it. So, thank you.
Thank you, Brian. Shashank Tiwari from GE.
So GE, as many of you may know, is actually a company that is very old. It's probably, if you add up the sums of all the companies out here, it might still stay older than that. Right? So it's really, really, really old. So just for statistics' sake, it's the only company that's still in the original Dow, out of the Dow 30 that was made. Every other company's out. This is the only company that's remained. It's a company that started with, sort of World War I era, went through the Great Depression, World War II, so on and so forth, technology evolution, and now, right? So now why I'm saying that is because it's important to understand that this is a company, as you're obviously an old company, you have a lot of baggage, so to speak, right? And you are a company which has its roots not in the digital, but in the analog world, right? Because things started out then. But having said that, what GE realizes is that the future really is in the industrial internet or the Internet of Things, and which is why it becomes so important to understand that a company which has been there for so long, which is really like as old and as sort of archaic, so to speak, is kind of looking forward in the future and investing actively to make that happen. So that's the important takeaway there. In order to do that, GE actually set up a completely new center in the Bay Area. GE was never there, so to speak, as a independent entity in the Bay Area. And so they set up a big center, which is part of the GE's global research centers. It's actually in the East Bay in San Ramon, just an exit off Pleasanton, if some of you guys know. It's a big center, which is there's a plan to make it a few thousand people, depending on how many people are required to get things going. Now, an important point in this whole investment and this whole story and trying to get people together and build this platform is essentially to see whether we can make this happen. So let me kind of start moving and see what is this that we are trying to make happen, right? What is it that we're talking about? And some of these, I'm not going to really go through the slides. I mean, this is just really for context. But the important point here is that, the technology evolution has been pretty rapid in the last few years, right? So let me just, we have a mixed crowd here, so that's good. But, many times I go to meetups and I start talking about technology and people start looking at each other because some of those technologies didn't exist when those people who were in the crowd, started out with technology, because it's a very young crowd, so to speak, right? But that's not totally true about this meetup here. So you guys were just kind of roll back 10 years, not even that far back. I'm not talking about the reflection way back, through your childhood or something, but just go back 10 years and you would have seen in 10 years, we have really rapidly progressed through a lot of different technologies, right? So today is what? This is 2013. 2003, Google was barely known. I mean, it was there as a search engine. It had proven to be like a great search engine. It was hardly there though, not in the scale that we know of today. iPhone was not there in 2003. This device wasn't born in 2003, right? We didn't have many of these things, things that exist in your cars today. Most of you drove to this spot, many of you have very easy access to GPS. 2003, getting hold of a GPS was pretty hard. I don't know how many of you guys tried using, GPS technologies of that day, right? Right now, you can use GPS on the same device, the phone. You don't even need a separate device, right? Using Google Maps and navigation, right? It's as simple as that. So all I'm trying to say is that things have moved very fast. And what has happened is that all the excitement that has happened in the consumer world has sort of woken up the industry, so to speak. Like everyone's now looking at the consumer world and saying, well, a lot of interesting things are happening and they can be brought back to the good old world of business, and exciting things can be done there. And that's basically the inspiration. And that's also one of the things which companies like GE, which are sort of, so to speak, old school, are looking at saying, well, what can we do as a large industrial conglomerate in terms of all these exciting things that are happening in the consumer world. Excuse me. How can we do it in the business world, right? Now, I don't know how many of you guys know, but GE really is a very diversified company. So we are in all kinds of businesses, so to speak. We have certainly a home business, as you said, lots of things like from dishwashers to electric bulbs to things like those that we make, right? But that's a very small part of the whole GE's business. That's just one which is more visible because it's in our homes and we see that little logo there, right? So we kind of recognize and associate with it. But I don't know how many of you guys know, but we are like the leaders in the whole jet engine category, for example. So a majority, over 50%, 60% of any airline that you fly in the US is probably powered by one of the jet engines that made by GE, just as an example. And we go not only just with commercial jets, but fighter jets, many of the rocket parts, stuff like that, right? So people have been in that business for a long time. We also have a substantial stake in the energy business. So we have things like wind turbines to regular energy management to a lot of thermal-based energy from generation to distribution to a lot of those kinds of businesses, right? We are big in the water distribution segment, transportation, things like rails, right? We are also pretty big in many other segments like oil and gas exploration segment, and a whole lot of others. I mean, there's a lot of the industrial segment, so to speak, the industrial automation. Let's just put it that way. So now why I'm saying that that's important is that all of those segments heavily depend on automated, complex, smart machines. Healthcare, of course, I forgot to mention that, but healthcare is another huge segment, right? So in fact, most of the leading machines from CT scans to just about radiographic machines, there are a lot of those are manufactured by GE, right? So all of those machines today are essentially smart machines. Let's put it that way, right? Now, what I mean by smart machines is that each of those machines have not one, not two, not three, but a ton of sensors in them. For example, let me just ask you a question. Just take a guess. How many sensors are there in a jet engine, that powers one of, let's say, a flight up there? Just take a guess. 5,000. Yeah, it's in that range. You're absolutely right. So it's thousands of sensors, right? So just think of it that way. It's not one, it's not two, it's like 5,000 per jet engine. And there are like 2 engines in most planes, and some have like more engines. And if you look at a fleet, right, there are how many flights are there in the United States every day? There are not hundreds, not thousands, but there are hundreds of thousands if you start counting international airlines and if you start looking. So if you start counting it and you just do some simple math, you'll realize that we're talking about some huge amounts of data that just gets collected by these sensors every day. And as I was just talking about, this is just the aviation business. Then you have the same thing about power generation, same thing about wind turbines, renewables, things like those. So each one of those are just full of sensors. They're just collecting data. So the important thing that becomes for us is that, we certainly want to collect all the data, right? But then what do we do with that data? So we can do many things with that data. I mean, we can certainly make the machine smarter, right? So that's one thing. We take all that data and build some sort of an intelligence in the machine. Now, intelligence in the machine can be built again at 2 levels, so to speak. One can be at the local level itself, like the machine itself is sort of self-cognitive, understands what it should do, right? Take a few decisions autonomously without necessarily human intervention. And by the way, that is all very common. It may sound like some AI out there, but it is not. It's pretty common. So much so to the extent that, let me ask you a question. How many of you drive a Prius here? Some of you must be driving a Prius. I'm pretty sure it's pretty common in the Bay Area. So, for example, pretty sort of easily available car like Prius uses the technology called fly-by-wire, which is used to fly planes actually. So a lot of that you see is no more those gears and axles actually mechanically moving things, right? And there's a lot of autonomous work going on in terms of, let's say, the battery charging. The engine is pretty smart enough to know when it should go into the charge mode versus when it should start, using the battery power and so on and so forth. So why I'm saying that is that a lot of machine intelligence can be built locally within the machine itself. Now then, beyond that, there is a second dimension, which was mentioned about, let's say, the smart car company that picked up a lot of data, that what will you do with all these tons of data that you collect, right? So there is a humongous amount of opportunity there. You could basically learn a lot of things that you may have never thought of. You would explore a lot of different hypotheses also and figure out what should be looked at, say, to make your engine better or to do your maintenance on time or to, whatever, make it more reliable, or just make some decisions without necessary human interference. So there is a ton of that, which in terms of machine intelligence. And then the third aspect, of course, is just the humongous amounts of data, because as I mentioned, there's just so much data being collected. Well, you got to do the standard things that you got to do with data, which you got to store it and analyze it and move it, and also kind of satisfy various levels of querying across the data set, right? So there's going to be some batch, long-running jobs. There's going to be some very instantaneous, interactive type of querying, and so on and so forth there. And then, of course, the fourth part is the analytics, which essentially is where we are looking at just smarter algorithms, or just algorithms themselves kind of getting smarter as you do more. There are also a few more important things which makes the industrial internet, or the entire thing that we look at GE very unique and different from, so let's say, a social networking type viewpoint, is some of these parameters like safety, security, and determinism. Now, why I'm saying these are so important is because you wouldn't want to fly in a plane where the engine kind of is quirky or doesn't feel like behaving the way it should be behaving, right? Would you? So it's one of those things. Many of these power generation units, if they don't behave as they're supposed to behave at the right time, have outages or problems, could actually lead to severe amounts of loss, not only monetary loss, but actually a lot of other damages, including perhaps harm humans, right? So we cannot take a chance there, or rather, let me put it this way: the amount of chances we can take are very limited in that sense. We want the machines to behave in a deterministic way, and more so especially when they become smart, right? Otherwise, there's also this whole I guess the weird AI horror of machines taking over humans, right? So so you don't want them to be super smart either. You want them to be smart, but you want them to be deterministic. The second part is safety, which I think also is very important, because you don't want it's miserable when your, let's say, a social account gets hacked, but you can still kind of live with it, so to speak, right? Your Twitter account is hacked. It's not really, it might be damaging your, let's say, credibility or profile or something, but it's not really killing you. But, if some of these critical systems, again, because they have an impact in society in general, multiple ways, if they compromise on security, it could have huge repercussions. Funny enough, though, I don't know if how many of you guys have heard about this, but, a few months back, there was a conference up in Europe, and a guy basically said, well, I'll show you how to hack a plane in flight. How can you get the engine data right now? I don't know how many of you guys have heard of this. Some of you must have, right? And he actually demoed it. He said, I'll do it right now in a very simple way. And he actually called up the call center, got some details about that flight, and some things he needed. But it was funny that he could actually even hack into that system. Now, obviously, he was benign hacker. He didn't mean to harm anything, so he didn't do anything. And sure enough, of course, it was a little hyped also. It was not like he was going to actually make the engine behave differently. But having said that, the important part is even to have access to that kind of data is risky, right? And we don't want that. The security part becomes super important. Now let's get to the second part of the story. And again, I'll try to rush through it. I don't want to take up too much time here. But so the second part is that most of the machines, when they were traditionally built and the way they've evolved, is what we like to call, they were very kind of physics driven, so to speak, in the sense that all the innovation happened in the machine parts themselves. So if you look at all these innovations, especially, let's say, the interesting part is your Aerospike story, for example. So a lot of innovation actually went in how you build that nozzle or the spike on the top. And there was tons of years of work just around the aerodynamics of those small parts, right? And sure enough, that's important. I mean, machines need certain physics and, precision in terms of, the sort of machinery itself, the engineering of the machinery. But having said that, I think what we think is that the next generation of power will come from actually the software that will run on those machines. And increasingly, that's what is happening in the sort of industrial space also. Because, the machine technology is increasingly getting kind of commoditized. For example, maybe a few years back, it was pretty hard to build a CT scan machine. But today, that technology is known. So many companies who are smart at manufacturing could say, for example, just for the sake of an example, build that machine. So now the differentiators of the value add really come in. Can you make a smarter CT scan machine? So the scanning technology itself is kind of done. The problem is solved. But can you then get more analytics and make it smarter, make it personalized? The patient goes in for a scan, and then the machine knows the history of that patient, for example, right? That these were all your past scans, and this is what we figured out. And so I should probably focus on more scans in this region as opposed to a general scan. Let's assume the machine does that, okay? That is a lot more value adding than, just innovating on the machine itself. So that's the kind of second part to that. So let me kind of jump through some of these. I'm not going to talk about this slide. Let me just talk about the data volumes. And I think I have probably one more and I'll be done with it. So we always talk about the social networks as a huge hose pipe out there, right? Just generating humongous amounts of data, and they are for sure. I mean, there are various numbers. I don't have it off the top of my head. I'm sure some of you probably know it, but I think the amount of data that was generated from the beginning of mankind till 2008 was generated in the last 2 years or whatever, something like that. There is some number. I think if you Google for it, you'll find it on the net, but it is true actually. So yes, the amounts of data that is getting generated today is humongous. It's a lot, and social networking is one prime example where a lot of data is generated at a very fast pace. For example, there's 80 gigabits per day of data generated on Twitter, just as a sort of a data point. And in fact, if you speak to guys from Twitter and from Facebook and other companies, when these companies were rapidly growing, one of the biggest challenges they had was not analytics. It was actually about just making sure that there are enough disks out there so that as the data was written, they would actually have some space to go for the data to be written on. Literally, they would rush there and just add some more onto their racks out there. So make sure that there's enough space that you could go and write and keep writing. Now, if you look at a GE kind of scenario, this is just one example. It says gas turbine that is in operationally there, and obviously all these have tons of sensors. They actually generate 588 gigabytes of data per day. Just one turbine, right? Now, so we got to be a little smart about it in the sense that we also need to be smart in terms of how we save the data, how we compress the data. Should we save all the data in some cases, or should we be selective about saving the data, right? So there is a lot of other challenges that also come in. And then there is the big problem that people sort of worry about in the big data world is that should you make a choice up front in terms of what data should be saved, or should you just save everything, dump it out there, and then figure out later, whether the data is good for you to save or not. So that's that's essentially that, and this is pretty much the last slide here, which is giving you just a sample, in terms of the amounts of data and how you could essentially add value at different levels just by analyzing the data smartly. So, for example, I'll just take the aviation example again, because somehow the aviation examples make good examples, I've realized. So, they're just like the, I guess, nice, fancy aspiration value. Flight has always been one aspiration for humans, I think, despite the fact that we've kind of solved that problem. So, no, seriously, I think flight has kind of defined human science innovation, so I believe. I mean, when humans crossed the sound barrier, it was really bigger than most of the things we had done, right? When man reached and stepped on the moon, that was, again, like the thing that we had done. So, yeah, going back to this whole space flight concept, many of you may not realize, but, small trajectory changes in a flight path could lead to substantial variation in terms of the amount of cost of that flight. Because the amount of fuel consumption also depends exactly on the wind, depending on the altitude that it flies in and things like those. There are a ton of parameters there, right? So even if we optimize, let's say we use the algorithms and said, you know what, just the way you descend, if you just change the way you descend a little bit, say in San Francisco versus the way you descend in New York, JFK, that could actually lead to substantial amount of savings. Now, today we can't do that because we don't want to get tricky with all these flight things. We don't want to run into an accident just in order to save some money. But if we had smarter machines and we actually had the data on time, right, and we had those smart algorithms which we built, say, with past, 10 years of flight or 20 years of flight data, then I think we'll be in a situation to do that. So there is a lot of, potential gain out there. And beyond that, there are more, I guess, simpler gains, but straightforward gains where, today, and I will kind of close on that, and maybe we'll have more in Q&A, but most of you are aware of the fact that our world runs on time-based maintenance. So your car goes on maintenance, 5,000 miles, 10,000 miles, 30,000 miles, 50,000 miles, right? There is a time-driven maintenance. Your appliances, warranties and maintenance are on a time-driven maintenance. And everything else in life is pretty much a time-driven maintenance, right? 6 months something happens, 1 year something happens. The same thing is in the industry also today, by the way. And what happens in the industry is that most of these service level contracts, which could even make or break your business, are based around those contracts, whether they're actually used or not used. It's pretty much like insurance in some sense. In the sense, if you start failing all your timely driven contracts, right, and they need more and more maintenance, then too bad for you. You'll probably be out of business very soon. So now if you flip that out and just question the whole story, if you're, let's take the car story, since all of us are very used to it, right, and we understand that problem. Say at 5,000 miles, my car is just fine and I have been super diligent about maintaining it well. Should I still go for a maintenance? Does it really make sense? Should I not, right? So because we're so tuned to it, we think like, yeah, we should, because 5,000 miles, how could I skip my maintenance? But the fact is, what if it was more event driven or behavior driven or very personalized? Maybe your car needed maintenance at 8,000 miles or 8,333 miles, who knows, right? So all I'm trying to say is that there is a lot of opportunity in just the whole maintenance space, which is huge for a company like GE, right? Because a lot of us is around maintaining these various assets that we have. I think that itself is a humongous opportunity. So anyway, on that note, I'll kind of stop here. I've already exceeded, way more, I think, like maybe 80% of my time. but thanks very much, and more in the Q&A. And over to our next speaker.
Okay,
Yeah,
thank you very much. So now we have Sukanta from QuickPay.
My presentation is not that colorful. You won't see many pictures, not a lot of billion-dollar stories. I work for a small startup based in San Francisco called QuickPay. We are in mobile parking and mobile payments. I'll move this thing so I can have some room. So before I start, has anybody heard of this company? Oh, wow. That's nice. That's really nice. We are just about 2 years old, and not a very exciting space. Parking, I mean, it's not that exciting. I generally don't get to wear this. I'm in garages, so this is my time to wear it, so I'm going to keep it on. But when I started the company, I was a little unsure. I mean, my friend is a close friend is the CEO of the company. I was a little unsure whether I would actually go into parking space. Because at the end of the day, with maybe $500 million at a billion-dollar business, is it worth enough, right? Today, North America does $26 billion in parking. $26 billion in a segment that nobody cares about. Everybody parks. Everybody hates it, I'm sure. There is not a single exciting thing about parking that people like. But you have to do it. And there are some problems. And that's where entrepreneurs like to go and innovate. I've been in startups majority of my career, and always solved really, really complicated, high-end problem solutions which take 2 years to build. This was the first one where it didn't take that much long time to build. But interestingly enough, Internet of Things, I actually stumbled into it. I didn't plan to. I read, I knew what they were, I knew what Cisco was doing, I read about GE. Exciting. I was excited to read those things, but it just happened that when we were building a solution and looking at ways to make things better, it ended up that those things kind of fell as a requirement in my lap, and that's how we kind of stumbled into it. And this is the only icon or image you'll see. You won't see any more. We don't have much. Before I jump into what we do and how we ended up building a Internet of Things device, let me talk a little bit about what my understanding, my read, my findings. And there's tons of paper. Actually, a fantastic paper from somebody from Cisco talking about Internet of Things. Beautiful projections on what is happening, where the segment is going to go, how people would be interacting with machines, with devices, talking cars, talking planes, talking trains, maybe. But at the end of the day, the problem that we have to solve, I mean, you guys are solving this, and my esteemed colleagues are solving it today, is that it's essentially the growth of data. More devices come in, more components, smart, unsmart, things which, pump in 2 bytes a second, and some pumping in 2 megabytes a second. At the end of the day, what ends up happening is a lot of data gets into the pipe, into the internet, the highway. And as these things go in, somebody wants to do something about it. I mean, things are going in. There must be a reason why it is going in. And that's where, smart companies like Aerospike come with good solution to help companies figure out how to capture them, how to mine them, how to be responsive in a real-time basis. And while these opportunities open up, it actually helps the customers, the businesses, ask smarter things. They actually would be, asking for a solution that you think you want to build. So that's the segment that I am in. A lot of these solutions that we're building are things that the customers feel that they needed, but they don't know how to get it done. And QuickPay presented an opportunity to go and address these elements. Since data is where the business is growing, and data is where we all want to go capture, mine, figure out value-added solutions to build, and offer our products, through our companies or the companies that we work with. We want to figure out how the data goes in, what kind of data goes in, what are the data items that we actually want to filter, read, understand, and the ones that we want to just bypass, just let it flow. And as innovation comes from the switching, the routing, the SDNs, the data storage companies, the caches, the clusters, the high availability solutions, as these things come in, that opens up opportunities for entrepreneurs like me and like you guys out there to figure out what new things to build and how to build it and which elements to go capture. So at the end of the day, Internet of Things is actually Internet of opportunities, tremendous amount of opportunities. If you just drive around the Silicon Valley corridor across 101 or even 280 for that matter, you'll see tons and tons of companies who are going and capturing a small portion of it and launching products, launching solutions, launching offerings which go and address these problems. And some of them are big. Everybody talks about big data. We actually talk about small data. There is real small data that goes in. And this small data has a lot of money associated with it. Everything that an enterprise does, we have to deal with it. Whether it's security, whether it is availability, whether it is latency through which things come in. We have solutions out there in the market where when you go into an expensive hotel or an expensive building or areas where there is valet, you have the valet treatment. We are building these things for average people, for ordinary people like me, who can't and won't pay $75 to somebody to park a car. We're building those kind of solutions. We're trying to bring those kind of convenience and those kind of simplicity into the space. A lot of it starts from the mobile technology, which initiates, but we are building solutions in the connected car space. I mean, there's a ton of things that I can talk about, and I literally have 6 minutes to go through this. As I said, QuickPay, we are a mobile payments, mobile parking, mobile payments company. Mobile payments essentially was a byproduct of since we wanted people to conveniently start their parking session through their mobile devices, cell phones, iOS devices, Android, the Blackberries, the Windows Mobile, and so on and so forth. Making it easier demanded that we have an integrated payment platform into the solution. So we ended up becoming a payment platform, ended up building a platform, we becoming consumer for it, and then we are looking at opening up so that others can use it. But at the end of the day, what it funnels is a transaction that is going through the system, and the transaction has a cause. The cause is parking in this case. Now, why are we talking about Internet of Things? When we started doing deals with some of the operators, we sort of sit between the B2Bs and the B2Cs in the world. My consumers are consumers who actually use the solution in the mobile phone to start the parking session. But my customers are the ones who actually host my solution in their garages, in their facilities where parking service is offered. So I kind of sit between them, trying to make sure both sides are happy. One side wants a lot of money, the other side is, paying the least amount of money. So I kind of bridge that segment. While we were investigating how to make things better in gated garage solution, we kind of stumbled upon how we could actually solve the problem by allowing a little device that could sit inside the garage, inside the gate arm, which nobody looks at. It's rusty, it's dusty, there's cobwebs in there. I've done that, so I know it. But what ends up happening is that there's a little sensor which sits in there that we built. And this sensor keeps on constantly monitoring what's happening. Who gets in, who gets out, at what time. And as we started collecting that information, this whole thing dawned upon us. We don't really need an enterprise $300,000 analytic system to analyze what is happening in the garage. Through the device that we are monitoring and the data that we're collecting on a real-time basis, we can actually go and tell a parking facility or an operator how many cars are in at any point of time, and based on what they're doing at 12 o'clock on every Tuesday, how many more can be brought in. And that solution is goldmine for them. They have no way to know these things. There are human beings which are doing that at 4-hour interval and 12-hour intervals. So we actually made that thing happen in real life and automate it. So from my point of view, Internet of Things is actually these little small things which brings in so much convenience and so much value from a customer's point of view. Customers being the operator, customer being me as a customer. I could actually, while driving on 101 in Palo Alto, open up my mobile phone, which I shouldn't be doing, my wife would be doing that since I'll be driving, and she can locate where we are going to go, right? She can locate, well, she doesn't drive when I drive. When I open up she'll open up the mobile phone, she'll locate where we're going to go, and 20 minutes, 30 minutes before I go there, she can actually book my parking. So I'm not running on 11th and 12th and Folsom and Howard locating a parking spot. If I have to go pitch to a VC over there, I'll be on time. If I have to close a deal, I don't have to apologize why I'm 15 minutes late. So these are simple things, but impacts most of us on a daily basis. And some really exciting stuff that actually comes out as byproduct of this is as these data gets collected in, we can predict at any route what is the traffic load that is going to happen over there. Which means we can tell ahead of time, don't take the 11th Street exit because in the next 15 minutes it's going to be jammed up with 2,000 cars backed up. This is, these are things, this is a byproduct of what Internet of Things is. Simple, easy, but it can solve so many problems. If anybody's done this thing, I do it. My office is in the city. I live down south. And sometimes it is an hour and a half, sometimes it's 2 hours. There is no way to predict this. And this is living in Silicon Valley, the best technologies of the world, the best, consumption of technologies of the world. And I'm still sitting over there honking and listening to my music because I can't get there and I have no idea how to solve that problem. So these are some of the innovations that Internet of Things can actually solve. And the only reason I'm talking about is not because we are so super cool about it. These opportunities do exist. The amount of data that all these smart devices, the GE devices, the Cisco switches, Cisco has deals going on with city operators where they're collecting all these feed and distributing it. Whether it is the government agencies or the private agencies out there, they are funneling this data out there. There is tons of opportunities for people to go and figure out how to innovate in the space. I have 37 seconds left. Again, going back to the world of opportunities, the amount of data that these solutions are collecting, these solutions are actually putting into the system, internet being a pipe, we just have to figure out how to consume and what to consume. And there are great solutions out there that'll make you, make the selection, help you do the choices. Internet of Things is actually Internet of Opportunities, at least for me. And I'm sure you guys are, excited about looking at new things to build in that space. Thank you.
Thanks a lot, Sukanta, and thanks to all of our panelists for giving us such a varied perspective. So we would like to open it now to all of you. Okay, you raised your hand first.
Yeah, hi. I'm Sunit Randhawa, and I am working for a company called Big Data Charts. So it's great to know the billion-trillion-dollar plans from Cisco and GE. So the plans which you have is because you guys are closer to the data. You guys have access to the data which the data analytics can be run upon, and where the algorithms can be put in place to bring the meaningful or actionable insights. So my question is, as you are building the empire to hire people and to go in this space, people in this room are also some entrepreneurs out here, or they want to also participate in this whole wave of Internet of Things. Can there be an opportunity where the data as it is, proprietary or residential within the enterprises, can be exposed? The privacy can be removed. The privacy information can be removed, but it can be exposed and small entrepreneurs can get that data and can run and can do more innovative algorithms on it, and we all can be part of the same Internet of Things wave and can build more innovative solutions. Can there be a possibility like that?
I can take this. So absolutely, the answer is yes. If you look at a smart city architecture, a smart city combines transportation, healthcare, education, all those data are coming. What you will see is that there will be a new a broker or exchange, information exchange or broker that will be responsible for the privacy and the policy and what information goes to what. Give you an example. In the healthcare, you have so many stakeholders. You have your insurance company, you have your pharmacy, you have your general practitioner, you have even your own private thing. So your own social circle. So the who gets what information is got to be very careful. Same thing for the traffic. I mean, if you look at transportation, there is auto OEMs who wants to do about diagnostics. There are people about traffic management. There is about the good driver behavior, like progressives of the world. So they all need canned information, and they will be building on that. But what it requires is, as you collect all this information, I believe that there will be a different players that have to come and play this mediator or broker service, and they will be held accountable for privacies, and they will have to figure out what information is shared and not shared, and how it is shared.
So just to add, we have two customers. One's in the Bay Area called Bulkowski, another one in Exolate in New York. And in the advertising and behavioral space, they are exchanges exactly like what we're talking about. So these are data management platforms in advertising parlance. And as an entrepreneur, you can hook up with these guys. And you can say, I want to open an account with you. And when I see this particular cookie, I want to know the audience information about it right now. I want to know some randomized and aggregate information about their last behavior, et cetera. So we're already seeing this in the Internet of People, where there are these brokers. They're not household names, is the interesting thing, right? You do have to, I don't know if there is one yet for parking, right? But they're going to happen. These information exchanges, they already exist in advertising and behavior. I believe that they're going to happen with Internet of Things as well. They have to.
So I can just add another dimension to it, not to just keep going with that same question. But so for a company like GE, we certainly are looking at a whole partner ecosystem. There is no way on earth that we can build the entire end-to-end industrial internet alone, all by ourselves. For example, our sets of customers, vendors, suppliers, the companies that basically do, let's say, maintenance on our behalf, and everybody else who is some sort of service provider would certainly be part of the story. So that is definitely there. I think the other part is, I think you mentioned more in terms of individuals. I think that was probably a question in terms of, can individuals actually use that data and do something with it? I don't know if we will do anything like that, considering that we are a very business-to-business type of an organization. So I don't know if it's really relevant for us there. There potentially may be cases where it gets relevant, especially with the things where we get closer to the consumer space, but I don't even know about that. I don't believe that's anywhere happening immediately. What we are doing, though, apart from that, is that at least in the Bay Area, so the other reason, just to mention why did GE even set up this center in Bay Area and why that is relevant, is because there is an important ecosystem here where people are learning from each other. So, just for example, big data. I mean, if you look at the number of big data companies and the various offshoots of, the original things that kind of, emerged from those Google papers and things done at Yahoo with Hadoop, how things have gone so far, and there are so many different companies, that have emerged out of that small little humble beginnings, is that because people all around here are kind of learning from each other, and employees are kind of moving companies also, taking that knowledge along with them. So that is definitely going to happen. We certainly want to participate in that. Some of you may have heard of some of the investment decisions that GE made recently. For example, we took a stake in Pivotal, so which is a player like Aerospike, so to speak. Also solving the big data problem in their own way, and I believe that more of that will happen. I mean, I don't know for sure, but yeah, that kind of participation would continue to happen, and that I think would not only happen with, say, a company like GE, but I'm pretty sure that every other player in the segment would look at either partnering or investing or doing something or the other in the space. So it's likely to happen. Yeah, it's a short answer. Thank you.
Mm-hmm.
Yes, my name is Miguel Cobo. I'm working for Ericsson, the Swedish multinational. I would say, as an analogy to what you said, 50% of the calls in North America, mobile calls, come through our systems. So we're coming from the telecom world. More a reflection. 3 years ago, we initiated a study on Internet of Things. We wanted to really understand an outside-in view of this phenomena. I read the report from Cisco, more than 11 exabyte of data on the mobile that will be generated for mobile data traffic per month, which for those who don't know, it's an exabyte is 18 zeros, so it's a lot of data. And we realized that the industry is taking for granted a lot of things. And there are some basic prerequisites that needs to be fixed before we see the explosion of revenues. First, how we're going to fix the revenue sharing between those who own the networks and that need to pay for the infrastructure for that data to go across. That is an important factor. The other one is the price of the sensors, because things could be anything, right? A car is easy to manage. But we have seen companies that even put some sensor in a pill that you digest right here. So the price of those sensors needs to be cents or a cent to really make that. And then we realize also that sooner or later we will need to have identity management of things. We'll have to create a Wikipedia of things. We need to create some kind of LinkedIn of things, right? Because, of course, where will be the values on the connectivity of non-obvious or not trivial thing, right? And as I say, I was more wanted to know what was your opinion about, at least that was our findings, and we noticed that it will take some time before we can see this huge amount of money that in some reports are reflected. But these are important factors. And finally, also the authentication, right? Not only that we need to authenticate that those things says the right thing, right, as information, but also those things should be able to authenticate systems that are asking them information because of fraud and everything. Anyway, just a reflection.
Any comments on
I mean, I can definitely take a shot at it. I think first of all, I think I alluded that we have silos today in the vertical, and in the future, which could be somewhere around 2020, where I called a connected society, which is connecting things and people, and objects and so on. So that is what you're talking about, where everything comes to. So I think that timing is more. It might be somewhere after 2018, 2020. That's when it will be, because right now the industry is busy in vertically connecting their own and solving their own problem, and then the next opportunity is going to be when you do mashup of these different things. They are not supposed to talk to each other. The network analytics is not supposed to talk to device analytics. That's not supposed to talk to user data analytics. Now, when you mesh this three-dimensional stuff together, you create a new type of application that we have not thought about. Today, most of those things are linear on the same level. We can do network analytics, great. Someone, Google can do great user data analytics and so on. What's happening? When you start mashing all those things, new opportunities comes around. Talking about security. It's a very important that mutual authentication, identity management. I don't know whether, I know you're with Ericsson, I don't know whether the SIM is the answer to many of those.
Interesting debate.
Yes.
Definitely soft SIM.
Yeah. Well, then you have the operators really getting scared whether they lose control of the subscriber or not. So there's some emotional aspects and financial aspects of soft SIM and the impact on roaming and so on. But definitely it's going towards eSIM and that direction. But the authentication, the security angle is very important. Identity management is going to be a very key, and this is device identity management. So that's why I alluded that we have a specific group now looking into security, which is not IT security. And that's what we're calling an internet security, which means intelligent, unintelligent objects. Sometimes you don't have IP address. I know we are calling Internet of Things, but RFID has IP address? Really? No, right? so RFID reader has. So, but how do you authenticate? How does a sensor in an oil pipe, where you want to know that if the pipe temperature has gone more than 50 degrees, how do you make sure that a rogue sensor is not giving a wrong information and you're making those unintelligent decisions? So those are, I think the security is going to be, I think people who work on security, by the way, good news. I think the industry has always loved you guys. You always have been on top, but this is another huge opportunity, which is security for Internet of Things. And that's a huge opportunity out there.
So just to add to that small bit, I mean, this is not a company viewpoint or anything, but it's just my personal viewpoint. I think that you have to realize that I think a lot of this would happen for sure, because there is a lot of opportunity, as you know, a friend from QuickPay was saying. So the opportunity itself might drive some innovation, as always happens. But I think beyond that, if you just historically go back and look at it, and this is actually read somewhere, so I'm kind of stealing off a book that I read, the idea that most big innovations or big things happen when three things align. And I think if I remember that correctly, is good economy, fair competition, and critical mass. And I think that's what has led all along. For if then three things kind of align, then most big turning points happen. That's when, you know, the space wars happened. That's when internet boomed. Many of these happened on times when somehow, you know, all three have to match. So now if you look at it right now and you're trying to map good economy, I think hopefully we'll see good economy in future. We've probably seen the bottom out, so I'm not hoping we keep bottoming out further. Competition, I think, yeah, there's a fair bit of competition coming up with all these investments and people wanting to gain something out of those. And also all the other innovation that's going on. So that will generate some competition among big, small, and all kinds of players. And then the third one is critical mass, which time will tell how soon the critical mass will happen. They think the only thing that we have learned over the years is that the amount of time it takes to generate critical mass is just rapidly decreasing. So, you know, if you start looking at, again, innovation cycles, it took X number of years from, you know, say, aviation technology or automobile technology, whatever, to evolve. And then now if you start looking at current technological trends, including all the stuff that's happened in the world of mobile and smartphones especially, that's a great indication, right? It's now reduced down to even less than 3 months, right? I mean, Samsung comes out with 4 models every year, I think, these days, not even once in a year. So just my 2 cents to that.
I'd like to add one more point over there, specifically on the big dollars being quoted out there. I think given the traditional approach of quoting big market revenue generation, I did that. I said $26 billion. But what we are seeing today is a lot of it is cross-pollination of data going from one segment to another. For instance, I mean, I think there was a gentleman who was asking about, can we collect data? Can we innovate? SFMTA, if you go over there, a lot of the information is actually freely available. So cities are making that movement, right? That allows you to build a solution for advertisement, for instance, which will tell you in this particular location how many newcomers come in. You can build an application over there and go sell, go fight Groupon in the space that they could not innovate, right? So I think those kind of cross-pollination will happen. So you will see the dollars kind of spray over. There wouldn't be the classical devices and the systems and the switches that were being sold, but cross-pollination of information going from one segment to another. I mean, there are solutions out there that as you're driving, your information is being pumped in through the networks.
But I just want to
Yes.
phrase, because I think maybe you didn't get my point.
Mm-hmm.
My point is that the success that you have on the company is because you own those sensors, right?
Mm-hmm.
You don't depend on second source. Your information in your business is of the accuracy of your sensors, correct?
That's not true. Some of the information that we collect
Yes.
are sensors which are installed by the city,
Fine.
built by somebody else.
Fine. But if those sensors send wrong information,
Yes.
your business, you're out of business. That's
Correct.
what I'm trying to say.
Correct.
So without creating an infrastructure of validating the source, validating that the sensor are truly sending the right information, so you need to do much more than just collect the data. You need to validate that your source says the truth,
That's correct.
right?
Mm-hmm.
And then again, these exabytes of data that infrastructure which Cisco or Ericsson will sell, well, if we are not able to connect part of the revenue sharing to those who are transporting that information, even though it's boring, as you said,
Yep, yep.
there will not be any Internet of Things. That's all what I'm trying to say as a reflection.
So just to share one vignette from the advertising space, and again, I'm sure the advertising space doesn't, if you get one sensor glitch, no babies die. I like that kind of space. But there are techniques that do not require cryptography and do not require that kind of analysis. You can do it in other ways, right? So in advertising, what you look for is you look for spurious patterns. Now, how do you tell a black swan from a spurious pattern is an interesting problem in signal processing. But you do need to figure out where the robots are, where the scanners are, and where essentially fraud detection is happening within the internet in order to ignore those patterns. So there are some other ways besides sort of crypto secure technologies.
Remember stuck state.
Absolutely. Well taken.
Dave Shields, our consultant, Zurich, Switzerland. 3 points, and I think the last speaker touched on some of them briefly, tangentially. First one relates to intellectual property. In such dense, interconnected, interdependent nodes and networks, who's going to own the intellectual property generated? Or implicitly, will every participant give a free license to everyone else? That's one thing. Second thing is, what happens about product liability and warranty and so on in such dense interconnection? Who's going to be liable for what? The third question is, if everybody's in a node or in a network and somebody doesn't like it after a while and they pull out, causing consequential losses to the other parties, will the lawyers have a field day?
Are you a lawyer, sir? Just checking.
An economist.
Close enough.
Well, very interesting question. I don't know if any of our panelists is ready to tackle that.
I'll take a shot at it because we see some of this in advertising today. The chains of sort of liability and control and ownership are actually kind of common sense in a lot of ways. The only hard part is if you own a sensor, you sort of feel that you have sort of first rights at ownership of the generation of that sensor. And usually you have some rights to place it created by some ULIT, right? So if you're, I was working at a company called iControl, which has now created the home automation system ADT Pulse. And so ADT, when they install a system, they believe they have some ownership created by the installation guide that says, we can do X, Y with your data. The analysis that gets created is done by whoever's doing the analysis, right? So you've got those sensors created, then you've got the IP created by those analysis folks. Part of the business driver of Internet of Things is going to be selling those analysis, right? When QuickPay opens up APIs, because now they can not only, they have their own data and they're able to sort of do things with that data, they enable an entrepreneur. Well, I mean, it's pretty clear. QuickPay maybe did some analysis, or they're selling raw sensor data for less. Someone else creates an analysis for it. We've worked this out within the advertising space, and it's actually not that big a deal. Now, the liability problems, I don't know. That's hard. But once you know ownership, maybe you know liability.
So I would like to say something around the reliability. I want to avoid the liability, if you don't mind. So what we are seeing in the industry, and that is coming down, is a new consumption model. And I want to share with you a example of how the risk mitigation and the reliability is passed on from the traditional way, where you have the entitlement to the people who are making it. It started in the aviation industry, where the concept is power by hour. So you pay for the hour of operation, and the vendor is responsible for the uptime. So and that was in a very expensive jet engines and so on. Now that has trickled down even to the lighting pole. We're working with this famous lighting pole company in Netherlands. You have to figure out who it is. They put light poles, very well known, has been around for a long time. Typically, I'll give you an example what's happening with city. A light pole typically costs around 10,000 euro for Europeans out there. For physical labor and whole installation, per light pole is 10,000 euros. Now the cities don't have that much money anymore. And I don't know if you drive across Europe, you'll see some places the roads are lit up, some places it's dark. It's based on the ability of each city, and their affordability. What has happened is now that's been turned around. Now the vendor who's building the light and the light poles are responsible for putting it into the ground, and is sold as lighting as a service. And cities are paying per month, which is much more easier instead of paying 10,000 euro per light pole. So they can use that money for healthcare, education, and other places. What it also means is the people who are making those equipment are responsible for the uptime, so they're doing even better. By the way, example, when I was studying at a university in Netherlands, and my professors were from those industries, and the fluorescent light was invented, we had to do what is called a quality of service, which means make sure the light don't last too long because we want people to go and buy again. So so we were optimizing the product for our revenue, because that's the way we had the revenue. Your light has to go down, you have to go buy a new one. When you change the consumption model, which is as a service, now the responsibility turnarounds, now we are making much more greener, much reliable, and it's uptime, and there is a SLA around it. So I think those changes of consumption models are also going to drive the people who builds the infrastructure, builds those things, are going to be part of the owner, will have the responsibility.
Thank you.
Thank you. Is it working? I can just talk louder. Oh. Is it better?
No, it's the same.
Carry on. You guys can hear me, right?
Yeah.
Godfrey Chua from Infinetics Research, tech analyst covering machine-to-machine IoT and things like that. I actually have many questions, so I'm just going to pick one and maybe kind of steer the discussion a little bit more to the business model side of things in terms of how we can actually, from an economic standpoint, drive adoption of IoT. Taking the smart city as an example, because I think the panelists can all talk to different aspects of it, is, so we've been looking at the smart cities, various initiatives around the world, talking to some of the constituencies there, and I mean, obviously it's a very challenging process, a lot of players involved, a lot of bureaucracy to deal with. Ultimately, to try and push it forward, you need real economic drivers to get the cities really thinking, we can do this and we can pay for it, and it's not just going to come out of tax dollars. One of the things that have come out is parking, actually, could be one of the killer applications for it. So I'm just curious from the panelist standpoint, what other examples can you cite, especially Cisco, in terms of business models that are helping drive, you provided some examples already, but business models that can drive, for example, the smart city, what applications, services can help justify the investment so it's not just coming out of tax dollars.
So I'll start, and then please chime in. So cities have CIOs. I think I don't know if many people know that. Even San Jose has a CIO. And he's a very progressive guy, fantastic guy. But cities are looking, traditional way is, we did a parking meter in San Mateo and San Francisco, which we paid for it because the city didn't have the money. But that's okay. We are incubating Internet of Things, and that's great examples. But some of the city CIOs are looking, so you have to find a new way of monetizing. Now, you will be surprised that cities get tax dollar by where you live, right? So there is a competition for skilled workers to be in San Jose rather than in some other county. So cities will be competing with each other. That's the new economy we're going to go. Because when you have Internet of Things and when you have this kind of broadband capability, you will have a lot of the example was mentioned here, what was done by human is now automated. So the skilled workers, you need to attract the skilled workers, you need to attract the business. One of the way San Jose CIO is looking at is to provide that broadband in the city as automatically for the businesses. Hopefully the businesses will come, they will attract the skilled workers, and that will attract the businesses to come. So the broadband is by default, and they get the revenue through the taxation because businesses happen, they get tax dollars. So it's an indirect model of really funding a city rather than upfront, okay, who's going to pony up, let's put it. And so you have to make some bets, and that's how you would see some of the cities doing it, and as it becomes more successful, others will follow.
Quick follow on that.
Yeah.
Has Cisco done some studies to actually put some numbers behind that, maybe commission it with some professors or something? And the reason I'm motivated to ask that question is, it's funny you mentioned CIO. So I'm actually chairing a panel of CIOs on smart cities in Shanghai in 3 weeks.
Mm-hmm.
So if Cisco has some data,
Well, we have good examples of CIOs. We don't have. I mean, we are always looking at Chicago CIO and San Jose. Some of the ones who are progressive in their way to innovate their cities and how to attract talent. There is a and then talent attracts also businesses. So yeah, it is, and then you have to do upfront, and there also, don't forget that there is also another model emerging, which is public-private partnership, and that is also another way where cities can have to figure out, how to have this pub sub or public and private public-private partnership to do a lot of the things. In Europe, 33% of the roads are toll roads, and that's a public-private partnership. So you could see major infrastructure of that magnitude to be following some type of model like that. But I'm not aware of this. We have done. I don't think we have a study of that one, but.
I think it's something for an economics professor to look at, retention of workforce and things like that.
Yeah, that's a good one.
Be interesting.
Yeah, good one.
So just a sort of slight diversion to your question, actually. So I think you're absolutely right. There is a lot of impact on the smart city stuff, and this is, I'm not even talking much as my GE hat on right now, because there is a smart city initiative that GE will participate in, but I'm not even aware of those details, so I have no rights to speak about it. But I'm just seeing from just general trends that if you take that one step further and look at just agencies, so what I mean by county is, state governments and so on and so forth, there are actually 3 or 4 opportunities that I think are biggest in terms of just monetary value. One huge area is just energy consumption. So for example, if you look at it, smart meter has created both a lot of excitement and also a lot of opposition, because some people also feel that it kind of enters into the whole privacy realm, and you get sort of penalized for certain kinds of behavior, right? But having said that, the whole energy consumption is going to be a massive segment. Along with energy, there's also the other utilities optimization, so to speak. Water, something as mundane as garbage collection. Many of the cities have actually been struggling with it. If you just look at the city budgets, and most of the city budgets are actually available online these days. You can actually go and look at, say, all the Bay Area cities, what is the largest spending, right? You will see that most of them are actually struggling in these areas. For example, a lot of these cities have been working around, can we collect garbage once in 15 days instead of every 5 days, and things like those. You might think like they're totally inconsequential, but they really impact the whole, whether the city can actually pay its police force and have its fire guys on board or let them go. It's pretty much like boils down to those kind of answers. So I think there are a lot of data around those, which may not necessarily be the typical quintessential smart city, but just simply having data analytics around those is going to be a huge deal. The other segment that has gained some interesting traction in cities like New York and Portland and some others is just people participation in the city. So for example, most of the cities, especially the largest cities, I'm sure San Francisco has one, I'm not sure, but they have a lot of helplines that just help people with day-to-day things, essentially. They're like the 311 numbers, right, that you can call up for city support lines. Many of these cities spent millions of dollars just staffing people, providing support, providing answers around 311. Some cities have taken proactive measure of just providing an online interface to begin with. Some other cities have come up with things like mobile apps where you can take pictures of potholes or broken signs and actually just send them to the cities, and they then follow up on those. Simple measures like that have saved lots of money to the cities. There's a classic case, not to kind of drag on this, but that I read was apparently some district in Portland, there was a part of the business district in Portland that was suffering a lot because essentially what would happen is that there would be a ton of traffic jam around that in specific times of the day. And so nobody would want to go there, and that's where most of the commercial areas also were. By commercial, I mean retail and boutique stores and stuff like that. So they were really seeing a decline in the whole retail segment. Nothing to do with the product or the economy, but just that there was too much traffic and nobody wanted to be seen around there, right? And also this comes in back with our friend's problem of parking, because people won't find parking and it's just a pain and they wouldn't want to be there. And so a lot of people sent that feedback. And what the city did was they ran a lot of polls, from what I remember, just asking people who lived in that segment. And the way I think you could get back is again through your mobile phones when you were there in that street. That's the only way a poll was counted or something. So they actually wanted to hear from people, not just doing some armchair thinking, but actually on the street there and facing some trouble. And finally they came up with the conclusion that the best way to solve this problem is just block that road off. And they converted that whole patch into just a bike lane or something like that. That's the call they took. So you had to park like a few blocks away, and only if you were walking at a bike lane. And after that, that whole district saw like a humongous increase in the whole retail story. So I'm just saying they would have probably never learned that if they were going the orthodox way. So there are opportunities like that to learn. Yeah.
I have a two-part question. First question is for all the panel members. What are the three use cases or products you see both in the consumer as well as the enterprise space in the next 24 to 36 months? The second question is for GE and Cisco members. If you look at the big data evolution and explosion happened since Yahoo and Google published basically their R&D projects as a white paper. If there is any new technologies which is evolving there, is GE and Cisco going to publish that white paper well in advance so that a lot of startups can evolve around that?
So what was the first one? Sorry.
First one I missed. I think
First
24 to 36 months.
Yeah, the three use cases or products on the consumer and enterprise space for the next 24 and 36 months.
So you go with the first B2B, the enterprise space, right? and the Cisco consumer. You probably seen our Flip departure from Flip and Linksys. But I will try to take a shot. That won't be a Cisco viewpoint, in that sense. That will be my personal viewpoint. But in terms of enterprise, honestly, we are following the money, right? It's following the money where we are making the biggest impact. Oil well, rig in a box, right? It's not easy. If you look at oil extraction, there are about, throwing numbers, let me tell you a number. 10 terabytes of data is collected as you're drilling the oil sensors. And typically they are located in some parts where some people are not welcomed, or it is very difficult for you to have a lot of people over there. So you're collecting all this information. And you need to be, today, your backhaul often is a satellite link, a very narrow band satellite link. So you cannot send all those terabytes of data back to analyze and understand which way to move your sensors. So they are physical tapes that are sent by helicopters, and your oil well is stationary for 3 weeks. And then it get analyzed in Amsterdam or in Houston, and then it's sent back, and then they have the next way of doing things. So what they need is something that runs analytics at the location and makes a lot of the decisions, filters out, throws 98% of the data which are not relevant. That's the reality in oil well. 98% of the data are not relevant. That's that specific information that you need. So you need to do quick analytics and be able to make those decisions, and the narrowband satellite link should be enough to get you going. Why am I saying that is big? Because you know that oil companies make a lot of money, and they are measured by their oil reserves. Now, if they can reduce 3 weeks of downtime every time the tape runs out, that makes a huge impact. So they are willing to do a lot of things with us at big dollars. So that's one area. The second one would be from our perspective is the industrial plants, manufacturing plants. If you look at the manufacturing plants, you have equipment from Siemens, you have from GE, you have from Rockwell, and all those, they have all their legacy protocols, because that's how those industries came from, and they talk among themselves, but they don't talk to each other. So you need and something that will equalize so that you have the total view of the plant, what is happening on the GE islands. Siemens Islands and Rockwell Islands, and they can talk to each other, and coming over to an Ethernet IP-based network from Profinet, or from or in the oil SCADA or Profibus and so on, to an Ethernet IP, or in the vehicle CAN bus. So that itself is for us looks like the world of frame relay, ISDN, ATM to IP. We see a similar thing that will happen in the industrial automation, where we call this operational technology coming to Ethernet IP. That's a big task. One of the key differentiator is the deterministic Ethernet, which my colleague from GE talked about, because we knew those protocol existed for a reason, and as we move to Ethernet IP, we have to assure that the reliability of those Ethernet is matching what those protocols do. So there is a huge investment, and someone talked about Stuxnet. Those are very important. As you now make those plant, which were supposed to be isolated, as you make them connected to the world, the level of security that is needed and the connectivity over there is a huge area. And this goes for both deterministic wired network and deterministic wireless, which is even tougher. Huge opportunity on deterministic wireless, whether it is mining, oil and gas, or manufacturing plants. So those are some of the area. And the third one would be in the transportation, whether it's along the roadside equipments. These are along connected rail, connected road, collecting all those information. These infrastructures will be put out there for 15, 20 years. So the revenue generation from our point of view, both for the infrastructure as well as for the end-to-end system, is huge. Those are the B2B angle. And B2C, I don't know three, but the one that we are, or one or two that we are looking at, is around home automation. We have something with AT&T, Connected Life, and we want to see how we can replicate that. This is around aggregating all your Zigbee, Bluetooth, all those things into one hub at home, and then providing you that control. And health and wellness in the healthcare. So I'll pass it on.
Okay.
Sure. So thank you. So let me actually take the second part of the question. I'll skip the first part. I really don't have any comments on that. And I'll probably want the other panelists also to jump in on the second part. So if I understood the question correctly, you were talking about the evolution that's happening in the big data space, and what are we doing, and as and when we are ready with something which is breakthrough, would we be sharing with the world in some sense? So I would make it just a larger sort of question here. So in the big data space, there's a ton of excitement today. Our host Aerospike has got a story, and like I mentioned, a few companies and ourselves. There is a lot of story essentially right here in the Bay Area that's emerging in the big data space. Now, what is happening is that if you just kind of loop back, you have to understand that a lot of the excitement in the big data space happened really in the distributed computing world. So I'm really putting on my tech hat for a few minutes and just bringing in all the NoSQL and big data experience that I have, and I'm just trying to speak from that standpoint that a lot of this happened in the distributed computing space. So when you saw all those papers emerge from Google, they were really trying to tell a story of how they solved at scale problem from a distributed computing standpoint. So I'm talking about all those papers, about let's say the Chubby or Bigtable or GFS and all those things which kind of spurred this whole big data excitement, right? And then everyone knows now they've become legendary, those stories, but when essentially what has become now Lucene and stuff like that, but when Nutch was trying to solve the same problem, and then there were other companies also, even Cosmix was trying to build its own sort of big data platform. They all took inspiration from Google and kind of reinvented the wheel in some sense, but obviously there was no publicly available wheel, so they reinvented a publicly available free open source wheel out there, and it was all great. And a lot of that happened from, I think, from 2006 to about 2009, 2010. In 2009, 2010 actually was, to my mind, one of the biggest sort of turning points in this whole scalable large data space, let's put it that way, right? So we started seeing a ton of different NoSQL companies emerge, and NoSQL is actually a very weird and misused term, but because NoSQL essentially means anything that was not SQL. It's technically it was not SQL, but not relational if you think about it, right? But a lot of different platforms emerged, and now if you look at it, I think there's a lot of evolution that has gone from just managing high throughput and large volumes to going back to what the database guys have done over the years. So if you think about it, all the database guys have spent the last 20 years, 25 years innovating around query processing, around optimizers, around columnar formats, around OLAP versus OLTP. That's where all the work has happened, right? And there are a ton of great products in that whole space, right? From standard, good old relational databases to a lot of the data warehousing type of solutions, so on and so forth. And a lot of that has come into the big data world. So if you look at it, for example, today, a lot of the innovation that's happening in terms of how do we query faster? Can we do something better than MapReduce? Let's say, which is the classic thing that has been a quest for a few companies. And you see innovation from, say, something like Hawk that Pivotal is trying to build, or Impala that, friends at Cloudera are building. They're basically trying to go back to basically writing a query engine, if you think of it. If you get down to the crux of it, what are they actually inventing? They are writing a query engine. They're writing a statistics-based optimizer, right? All of these things that the database guys have been writing for the last 20 years, and many of you guys have been in this field, so you can probably kind of speak to that. And so a lot of that optimization is happening. The other thing that is happening is this whole element of real time. Now, real time itself is a pretty tricky term. In my sort of past life, so to speak, I spent a lot of time building very real-time applications for the financial service world, and that time, real-time really meant not even like milliseconds. Milliseconds was too much because you could lose too much money, not for any other reason. And so there was a lot of optimization at that point in time, just simply around getting data faster. And all those event stream ESP type of technology emerged in that world, right? A lot of event stream processing. Some of that is being brought back into the distributed world, because when we were talking about ESP, sure, we were talking about speed, but we were not talking about volume of data and speed. We were talking about small volumes of data, but just focusing on speed, on optimizing bandwidth, on optimizing, basically inverting the querying process, put a filter, run data through it, that kind of story, right? Now, when you take the big data space, you can't technically do that. It's too hard, especially if you're trying to run that through multiple gigabytes, terabytes, and forget petabytes. Petabytes is too much. It's easier to speak about petabytes. It's very hard to deal with petabytes. Let me just say that. I don't know how many of you dealt with petabytes of data. Give me that. Yeah. So it takes a while just to copy petabytes, right? Just to even copy a petabyte of data from drive to drive, it takes a long time, right? So I'm just saying, like, it's easier to say about that, but I'm saying that managing throughputs at multiple terabytes or petabytes is a totally different beast. Just even trying to manage that much data, just move that much data, just copy that much data, is a humongous problem. And I think that problem was solved with this whole Hadoop evolution, so to speak. At least it was solved to an extent where it became bearable, right? With this whole distributed HDFS file system, it said, okay, you know what, don't worry about the size, throw it in and let horizontal scaling just solve that problem. So anyway, long story short, don't want to keep rambling on this, but I think there is a ton of innovation happening, a lot of exciting stuff around querying, optimization, real time, lots of things that are going to happen in the big data space. A lot of that is happening from various small to large companies in the Bay Area. We have our own story. We are trying to play in that own story along with extending products, adding things, building things of our own. For example, we have a huge interest in time series data, because ultimately, if you think of all the sensor data, everything is time series data, if you think about it, right? There's a time point, there's some value, and then there is some sort of attack. Sorry, so anyway, so you'll see a lot of innovation there.
I just want to add one quick things on that one. There's a network approach to the data as well. And in Cisco, we're looking, okay, GE talked about real time. You cannot assume that you do something and something gets computed in the cloud and comes back in a real time, honestly. So when you put those challenges, scalability, bandwidth requirement, real time, then you would come to a different type of network architecture. Even analytics, you will come to a different architecture. So we have concluded that we needed a hierarchical architecture for analytics. So analytics at the edge, close to the device, is different from analytics in the cloud, but also means that the networking role has to change. If we have to make our service provider, if we have to make our customer profitable, we cannot have all the data pass through. So what we have started a concept of, and we are productizing, is called fog computing. You have the cloud up there, and the fog is more close to. So this is by the way, FOG doesn't have any meaning, but it's really the fog. If you are in a Golden Gate Bridge and the fog comes, so fog computing is a mini cloud computing in terms of compute, network, and storage, and a middleware that does the resource management across the peers. So if a edge device is running out of capacity, it can point to the peering fog device for it to do. So we will see those kind of architecture come to solve this petabyte and zettabytes of data, because otherwise the backhaul and the latency and the real time, all those things cannot be solved.
So yeah, I just want Sukanta and Brian to answer briefly. It's 9 o'clock already, obviously, of a very fascinating topic, and we will have to stop after that. So please go ahead.
Okay. So one thing that we face right now, opportunity-wise, beyond parking and beyond some of the validation concepts and stuff like that, is essentially the real-time aspect of data. A lot of information is out there. You can collect real-time, and you can localize it. As if you want to go build something of your own, there is a lot of infrastructure out there that gives you the data that you're not going to get from the traditional enterprise that you can get now, and you can get that filtered. So if you're looking at opportunities, like, look at that, because we do get that, thing, and being a small startup, we can do all of this. So I meet people, lots of people ask about what they could do around the fringe. That's where money is happening. The real money, it may be small, but it can be repeated. And if you go build these things focused on local areas, you can build a successful business and kind of replicate it in multiple successful areas.
Is anyone out there using Storm, Apache Storm yet? Yeah, a couple things. We're going to be hosting the Storm users group here in this building. I think it's the 26th, Monica? 24th, thank you. So Ted Dunning of MapR, also an NEA company like us, is going to be talking about real-time processing. I'm very excited about Storm. We're looking at it very strongly here as a real-time database company, because it forms a great interconnect pattern. We're hearing a lot of our customers using Storm and the Storm processing system. You need a level of reliability if you're doing Trident, for example, for actually keeping track of message reliability. So we're going to be thinking and working a lot with the Storm community in that. So consider coming out to hear to Ted Dunning talk about what MapR is doing and some of the real-time use cases that they have. What? 24th? 24th. And so it's on meetup.com.
Thank you very much to our panelists for a fascinating discussion. Thanks to all of you for being here and keeping the discussion lively. And we are all excited about a glimpse into the future. So thanks a lot.